Next up, we have Andrew Perong from Huntingdon Valley in PA, Pasadena, I think, in the good old United States of America. And we have a broken pedometer. Excellent. Thanks, Andrew. Let's check it out. A broken pedometer. What are we going to do with a broken pedometer? I guess look at it, right? There's a note in here. Dear Mike, wrong show. Did you meant to send it to Mike at Mike's Electric Stuff, perhaps? Enclosed is a Jawbone UP wristband pedometer that does not work, which I've lost the cap to. Unfortunately, Jawbone was kind enough to send a replacement. Do not need this anymore. I was wondering if you could please disassemble it on the show. Thank you very much, Andrew. But he sent it to the wrong person. Yeah, just be careful, folks. You know, I know to you Yanks, we do all sound quite similar. And here it is, and it's very unusual. It is the UP Jawbone pedometer. And check it out. It's got a TRS, a 4-prong TRS jack on the thing, and presumably you just whack it around your wrist like that, and you wander around all day, and it logs your steps and everything else. So yeah, go figure. I assume like it's got a internal rechargeable battery, and I'm not sure what it actually, you know, you must get like an adapter with it that plugs into your PC or something. Like maybe that's like a serial interface with power, and that's probably it. I don't know. I haven't looked up the details, but there you go. It's all nice and flexible, and it's got rubber. I don't think I'm going to wait for Teardown Tuesday. I think I'll just slice it open with a knife and see what's inside. And I'm trying to slice this thing open here, and it looks like there's this outer rubber which kind of peels off like that, but then it's sort of integrated into the inner rubber square core. So there's that outer one, and that's sort of all completely integrated into that bit. So yeah, it's not as easy as I thought. I thought I'd just be able to slice this thing open, but requires a bit more work. And I'm slowly getting into it in there, and you can see the metal spring bar in there. So of course the whole thing has to have a spring metal bar in there, and my guess is the battery's probably, or the battery and maybe all of the circuitry is down on this stiffer bottom bit down here, because you know there's probably a flex PCB going right through this thing, of course. But of course you aren't going to get you can get flexible batteries these days, but yeah, I mean I think it's just all going to be bound up down in there like that, perhaps with a few, maybe some components going off to the sides. I don't know, but yeah, gotta go right around this thing and crack it open. Oh dear, patents granted and pending. Whoop-de-freaking-do. And by the way, Mike did a teardown of the Nike Fuel band, and I think that's a competitor to this UP Jawbone. And oh, look at that. Is that what's that? Is it a magnet or something? I don't know. Gonna have to check it out. Aha, we're sort of getting into some wires and stuff now. So yeah, let me do a bit more work on this. So here it is, and it looks like it's actually assembled with like 0.5. I don't think it's 0.8 millimeter. It's probably 0.5 millimeter board, but it's not flexible. It's just gunked together like that. So when you flex it like that, it doesn't, there's a bit of give in there, but yeah, I think they've just used very thin regular fiberglass board in there, and this what looked like a magnet at first glance, I believe, is actually a piezo ceramic accelerometer, which I didn't really expect in this. I expected just a solid state MEMS type accelerometer or something like that. It certainly looks to be that same sort of round sort of machined shape as you get with those high-end, if you're familiar with the high-end piezo ceramic accelerometers. So anyway, patents granted and pending. I'm assuming that is the battery in there, and there's no other circuitry under there because we can see some chips on there. We'll take a closer look, but they seem to be on almost like separate boards. I'm not sure. The gunk in there's really rather annoying, and they've got you know what, 4 traces leading around to this over here, and I have no idea what that end piece is. Is there another accelerometer in there, and they're using, you know, different, just maybe getting a different reference point or something like that? So I'm not sure what actually is inside that thing. Go figure. But I mean, here's the and then they actually have wires running off. So from the board in here you can see a couple of tiny surface mount stuff in there, and then they have a bunch of wires just running down there into the TRS jack. I took the cap off the other end, and you can see that there's some sort of connector interface in there. Clearly some sort of you know, test slash programming interface for production. This wouldn't be for the user, I'm sure. Can't really see what type of connector that is though. Look, there's a center pad and there's an outer ring, and that's it. And it actually pushes in like it's some sort of tactile button. You can't feel that, of course. This isn't Feel-O-Vision, but trust me, there is a, you know, that's probably like a 200 gram force tactile switch in there. So maybe they attach the test probe, and the tactile switch says, oh, okay, so that when you put the probe on, it pushes the switch down like that, which then puts the thing into programming slash test mode for production or whatever, and then you use the 2-wire interface, ground and data there. So it's essentially a 1-wire interface to do whatever they need to do during production, I presume. And of course that makes sense if you remember before going into it, is this 4-way flex membrane. So you'd have 2 wires for the tactile switch and the other 2 for the external contacts. And there you go, no surprises, a TI MSP 430. This is the 430F 5528 in a BGA package on a what looks like probably a sandwiched flex board. You can see the PCB in there, you can even see the layers. I'll try and get a close-up view of the individual layers, but then you can see the flex board actually sandwiched in the middle of that, which then goes off to the next board over here, which then contains, I don't know what that is, it's an NXK, it's a TI 19W ZD6Y, bloody annoying numbers, you have to decipher those. But yeah, it all looks a bit of a mess because of all of the rubber potting compound around there. You can see more test pads, you can see little tiny like 0201 resistors in there, and a few surface mount caps. But there you go, you should be able to see the sandwiched construction of the board in there. If you look closely, you can see that that dark material in the center is the flex, which then continues out over here, and then it'll continue out the other side there, even though it's not obvious. And then you've got your regular fiberglass board above that. So that's not actually a flex board as such. That is a one of those hybrid flex in the middle type construction techniques, just to join multiple boards together. It's a very common technique when you need to put something around a circular enclosure like this. I've done this before on seismic products, where circuit boards have to be wrapped around a central core in the middle, like a central wire bundle, and the PCBs have to wrap all around that. And you do that, join the boards together using a sandwich flex technique. And they've got some more circuitry on another board in there, and it's like, and that looks like it's like got a conformal coating on top of that as well, and then it's surrounded by the rubber. And here's the other board where the wires come in from the TRS jack, and you can see the there we go, there's a good example of the flex membrane, which is sandwiched between the board I was telling you about. There you can see this separation in the two boards like that, with the flex material in the middle. So maybe I'll try and actually extract these boards, and then you'll actually get a better idea about that. But then look, there's a little SOT23 package, and that's all around the accelerometer there. You can see a couple of wires in, and I think I see another flex membrane underneath that. So man, it's like they've gone to a lot of trouble. They've got like 5 separate boards in this thing. And there we go, there's the flex membrane. That's under the accelerometer there. There's the accelerometer. You can see the 2 connections on that wired in. That's your main accelerometer. Whether or not it has like a secondary MEMS one, I don't actually know yet. But you can see all the boards joined up there, and that flex membrane would go right under that, and you can see it up there as well, joining onto the main processor board. And then another, you can see it in there, joining up all the boards together. And look at that, on the bottom side of the board, more components on there. We've got double-sided load. Now this is, as I presume, the battery module, but it seems really thoroughly attached to this metal spring back band on it. Now I was able to snap off, you can see I've snapped off this side of the metal band here, but I really can't get that apart. I mean, I prized off the rest of all the boards and all the flex stuff. I pulled those off, no problems at all. So if you can see that, all the others separate from the steel back band on that, but this battery in here just doesn't want to come out, the bastard. Ta-da! Finally cracked it. There it is. Yep, lithium polymer, 32 milliamp hour, single cell, 3.7 volts, with what looks like possibly a battery protection board in there as well, as you'd expect. And there you go, there's the back side of the battery protection PCB, and you can see the MOSFETs in there for the over voltage cutoff, and probably under voltage cutoff as well. And there you have it, it's completely out, and you can see the rigid flex architecture with the different boards all joined by the one flex membrane in there. Coming in on this side, we have the interface board. They're the wires coming in for the user 4-pin TRS jack. Then we've got our piezo ceramic accelerometer. There it's got its own little board. Once again, double-sided load on both of those. And that board, that rigid board, hence why it's called a rigid flex, that rigid board is just sandwiched, as we said before, between the flex material down in there. And that's how you join all the boards together, because you don't. That does the physical interconnection between the boards. So you don't actually need a connector as such. It's all manufactured and sandwiched in as part of the board. And then we've got our main processor board here with the MSP 430 processor. Once again, that's double-sided load, so that'll have some, voltage regulation and other support stuff on it. Looks like we've got some test pads there for production testing. And then, yeah, we've got another couple of chips around there, which we'll have to have a look at. That one and that one down in there with the test pads, and then that goes all the way down to that programming / test tactile switch interface. It's all, they've put a lot of effort into this thing to design and manufacture this thing. I'm not sure I would have gone to all that effort, and because it's all rubberized and conformally coated, and and all the battery was all potted up and everything else, then sealed, this thing would be completely waterproof as well, I'm sure. And there you go, you can see the bottom of the processor board there. You can see the crystal oscillator, few passive parts and stuff like that. This would really be a pain in the ass to assemble. The processor is on the top part. There you go, there's the MSP 430 again, and these really would be a pain in the ass to assemble, and you would have to go to a specialist rigid flex assembler who really knows what they're doing and can design all the custom jigs to actually hold all these in place while they're assembled, and really is tricky business, not something you would want to do willy-nilly, that's for sure. You'd want to have a very good reason, like, you know, this particular application here with the, you know, goes around a wristband. It's all very tightly integrated and stuff like that, because assembling these things would cost you an absolute fortune, and you wouldn't do it unless you absolutely have to. And that right there, the MX25L8006E, that's an 8 megabit serial flash from Macronics, and you can see it's a leadless chip carrier there. It's not a BGA, so that one's not as hard as the main processor on here, the MSP430. So, you know, these rigid flexes combined with BGA and double-sided load and everything else, what a pain in the ass to assemble, really. And that chip there, I was able to find the info on that. The NXK TI19W was what it's marked there, but it's actually a Texas Instruments BQ24230. You guessed it, lithium-ion/lithium polymer battery charger IC, because that's the only other thing needed that we haven't found yet. So there it is. That's like a USB friendly one, goes up to like 500 milliamps and stuff like that. So it's pretty much all there. We've got our main processor, we've got our lithium-ion battery charger, we've got our serial flash. Where is it? There's our serial flash for storing all the data. Of course, they don't have room inside the processor. And then we've got our accelerometer circuitry and stuff like that. We've got interface circuitry over here for our 4-wire interface, and that's, you know, about all she wrote, really. You know, all it's doing is, you know, there's some fancy algorithms in there to, you know, read and filter out the data from that accelerometer and figure out what's going on. But yeah, all the smarts is in there. Like, hardware-wise, if you looked at the schematic for this thing, it'd be, whatever. And by the way, this outer rubber here is supposed to be hypoallergenic TPU rubber, whatever that means. I guess for those freakoids out there who have some sort of aversion to rubber products. Aha, folks, I've been fooled. This is not a piezo ceramic accelerometer like I thought. I was originally, you know, quite perplexed why, you know, it would have a piezo ceramic accelerometer in here instead of one of the more modern MEMS ones, and so I did a little bit more digging, and this is actually a vibrator. This thing has a vibration alarm in it. Sure enough, I measured the coil in there, 32 ohms. So there you go. The accelerometer therefore must be a MEMS one on that processor board somewhere. And there are a couple of candidates on here. There's that bare die sort of, you know, flip chip down in there. It's got like JJN marked on it. I'm not sure. There's another device there with not much marked on it, the black one. That one there, obviously, I believe that's the crystal. And the other candidate would be this little sucker, which has 2400p and E1 something else on it. I've actually scratched the top of that with my knife when I was digging out the rubber, but one of those devices will be the MEMS accelerometer on there. So there you have it, folks. That's inside the Jawbone UP Pedometer, and that's you know, rather interesting. You know, it's not just a regular pedometer. It's the construction that really, you know, the rigid flex structure that really makes these sort of things interesting from an engineering design point of view, because, you know, it's not easy to actually design all the logistics and construction which goes into building a rigid flex board like this. They can be a real pain in the butt, and you're never going to get it first go in production, and it's, you know, you end up with all sorts of yield problems in production and all sorts of horrors like that, which you're at best avoiding if at all possible. But of course, to get in this sort of form factor, this is what you've got to do. I wouldn't have used so many, I don't think, but it makes sense to separate the boards, you know, separate processor board, separate battery charger board, separate serial prom board, and separate amplifier board, and separate interface board, I guess. There you go. But anyway, Fascinating. Thank you very much, Andrew. That was very interesting teardown. And if you want to discuss it, the best place to do that is on the EEVblog forum. The link will be down below. And if you like it, please like the video. Please give it a big thumbs up. Catch you next time.